Welcome to Spring LIB.
So in this problem, we are using protons to produce photons that on impact with the metal will produce X-rays. So basically, if a proton produces one photon on impact, then the total energy of a proton gets converted into the energy of a photon. And since the protons are accelerated from rest by potential difference of 4 kilovolts and then they strike a metal target. This means that the energy of the photon is E times the potential difference to which it is accelerated to, and this gets converted to energy of a photon. So F max. And since frequency is C over lambda, then for maximum frequency we have the minimum wavelength. So from this equation we see that the minimum wavelength is equal to hc over E times the potential difference. And this is the same minimum wavelength that we need to find to produce the X-rays. Not the X-rays, this is the minimum wavelength of the resulting X-rays. Now, 1 kilovolt is 1000 volt, and 1 electron volt is 1.602 times 10 to the power minus 19 joules, and Planck constant in joules is 6.626 times 10 to the power minus 34 joules times second. So we can substitute all these over here, and you guys know the speed of light, so let me just write that just in case. And okay, and this is the conversion factor. 1 electron volt to joules is the conversion factor that we will need to convert this potential energy of the electrons to joules. So this is in units of electron volts, and we will convert this into joules in order by using this conversion, so that our equations, all the variables are consistent and we can solve the equation. So that way we get lambda minimum to be 3.1 times 10 to the power minus 10 meter, and this is equal to 0.31 nanometer. So this is the minimum wavelength of the resulting X-rays. Now, in the case of using 4 uh, kilo electron volt instead of 4 kilovolt, so here voltage was 4 kilovolt. And also make sure you convert this kilovolt into volts before doing this conversion and before substituting that. Now, in case of using 4 kilo electron volts, we need H to be in units of electron volts as well, in order for our units to be consistent with each other. So electron volt per second. So now we will use the same equation, substitute all the values, and that way we get lambda minimum to be 3.1 times 10 to the power minus 10 meter, and that is also equal to 0.31 nanometer. So this means that lambda minimum is the same in both cases.